Let's practice some stoichiometry. This problem asks how many milligrams of AlCl3 are formed from 2.15 moles aluminum. We're given this equation, Al plus Cl2 produces AlCl3. So we're reacting aluminum and chloride together to form aluminum chloride. Before we get started with the stoichiometry problem, we want to confirm that our equation is balanced. So if we check here on the reactant side, we have 1 atom of aluminum and 2 atoms of chlorine. When we go to the product side, we still have 1 atom of aluminum, so that's balanced. But when we check the chlorine, we have 3 atoms. So we need to do some balancing. To find the least common denominator between the reactants and product side for chlorine, we see that we can multiply the reactant side by 3 to get 6 chlorine atoms, and the product side by 2 to get 6 chlorine atoms. So we'll go ahead and add those coefficients. And now that we've added the coefficient on the right, we have 2 aluminum atoms. And now we're unbalanced there. So we need to go ahead and add a coefficient in front of the aluminum on the left side. And now we check the left, we have 2 aluminum, 6 chlorine, and on the right we've got 2 aluminum, 6 chlorine. So we're fully balanced and we can get ahead with our problem. We're going to go ahead and start with the 2.15 moles of aluminum, and let's see the process we need to follow here. So we're starting with moles of aluminum, then we need to convert first to moles of aluminum chloride, and then we can get to grams. Once we get grams of aluminum chloride, we can then convert that into milligrams, which is our final desired unit. In order to find out how to convert between moles of aluminum and moles of aluminum chloride, we need a mole ratio. So we're converting between moles of aluminum and moles of AlCl3. And from our coefficients, we see that we have 2 aluminum moles, and 2 aluminum chloride moles. So our mole ratio is 2 to 2. And now we can go ahead and convert from moles of aluminum chloride to grams. And so first, how do we get from moles to grams? We need the molar mass. So we go to the periodic table, and in order to find the molar mass of AlCl3, we need to combine the molar mass of aluminum, which is 26.98 grams per mole, and the molar mass of chlorine, which is 35.45 grams per mole. And since we have 3 chlorine atoms, we need to multiply the molar mass by 3 to get 106.35 grams per mole. If we add those together, we can get our molar mass of 133.33 grams per mole for AlCl3. And then we can go ahead and plug that into our stoichiometry equation. So we have 133.33 grams of aluminum chloride for every 1 mole of aluminum chloride. And now we can calculate through to get 286.66 grams of aluminum chloride. Let's confirm that everything we did was correct for our stoichiometry to check that all the units canceled. So we got rid of moles of aluminum and moles of aluminum chloride, and we're left with our final units of grams of aluminum chloride. But we see in the question that we need to remember to convert from grams to milligrams. So that's our next step. So we've got our 286.66 grams of aluminum chloride, and we have to do a unit conversion from grams to milligrams. And with the milli prefix, we know that there are 1,000 milligrams for every 1 gram. And so that leads us to 286,659.66 2.5 milligrams of AlCl3. And so when you're doing unit conversions, it's always good to keep that value in your calculator because you see that the numbers change the more decimal places are allowed. But we need to look back to our problem first before we finish and look at how many significant figures we have to start with. And we have 3 significant figures. And this is way more than 3, so we can either change it to our 3 significant figures and get 287,000 milligrams of aluminum chloride, or we can convert this to scientific notation to get 2.87 times 10 to the 5 milligrams of aluminum chloride.